Which one will be faster? Is it on the straight line or
Straight
circular?
line.
Huh?
Straight line.
Yeah, straight line. So that is to tell you that the velocity will not be the same for straight line and for circular. That's very important, right? So that's why we need to learn how to calculate velocity for circular. Now, let me go to the next slide. Now, before we talk about the velocity, let's talk about the unit we use to measure. You know that in physics, everything have a unit, like meters, second. Give me two more units. Meter, second. Can you give me two more? La ilaha illallah. Can you tell me two more units apart from meters and second?
Kilometer.
Aha, I like that. I like that. Kilogram, gram, right? So many of them. So the same
Yes.
thing for angles. We need to know what is the unit for angle, which is radian. Are you following? Radian. So can you read this? One radian. I want you to read that on your screen. One radian is.
Um, 1 radian is defined as the angle subtended at the center of a circle by an arc equal in the length to the radius of the circle.
Very good. I wish I can draw something. Oh, yeah, I can draw. Yeah, I can draw because I need to quickly explain something. Now, by an arc, this is called an arc, something that is a part of a circle. This is an arc. You know, it's not a complete circle. We cut this from a circle. That's an arc. Are you following? Now,
Yes.
if I draw a complete circle, the radius of this circle is the line from the center to this place. Any part at all. I can draw from here to here. I can draw from this to this. But any line you draw from the center to the circumference, meaning to that part of the circle, is called the radius. Are you following? Now, one
Yes.
radian, that is a unit, one radian is defined as the angle subtended. Now, if I cut an arc, 1 minute, let me get a red pen. Okay, good. I want to cut an arc like this. I told you an arc is a part of a circle, right? Something like this. So this red is an arc. So I have this like this. You can see? Now, if the length of this arc, this red part of the circle, is the same as the length of the radius. Can you see this now? So let me say this radius is R, and for example, let's say this arc is A. So if A is equals to R, the angle here, can you see the angle I'm drawing?
Yes.
Aha. The angle subtended is 1 radian. Is 1 radian. So please don't forget that we are going to use that a lot in our subsequent what's it called, lessons, I mean explanation. So 1 radian is defined as the length, as the angle subtended at the center of a circle by an arc equal in length to the radius of the circle. Do you understand that explanation? Do you understand that explanation?
Yes.
Very good, very good. So let's go to the other part, which is also very important. Aha. Now, remember I told you that if we have if we have a motion in a circle, either a car or anything that is moving in a circle, it will have its own speed. That speed is called angular speed. Are you following? That
Yes.
speed is called angular speed, and it makes sense because if you have a circle, you are having an angle, right? So that's why we call it angular speed. And it is the change in angle Okay, let me just draw also so that you can understand better. If I have a circle like this and a car is moving in this circle, are you following? Now, if the car, let's say this is the
Yes.
radius, right? And this is an arc. You know there's an angle here, right? Now, if the
Yes.
car moves from this place, and continue to move like this, you know that if it gets to this place, the angle has changed. Can you see now? The angle has changed. So this final angle minus the initial angle divided by time is angular speed. Does that make sense to you?
Yes.
Are you sure you understand that?
Yes. Yes.
Very good. So now the formula for angular speed, omega, is equals to 2 pi divided by t. 2 pi over t. What is t there? That capital T, what do you think it is?
What is it?
This capital T, I said the angular speed omega is equals to 2 pi over t. And I asked, what is that t? What do you think the t means?
Ti-
Huh?
Time.
Yeah, you are very close. It is period. In the circular motion, you call that period, right? Period t, because it's capital. The small t is time. So when you write a big T, you call that period. Is that okay? So we are going to
Yes.
apply this formula a lot of the time. So please don't forget it. Now let's go to the next one. Yes, I have a puzzle for you. Fantastic. So which car will you
Puzzles.
remove? Yeah, you can see the puzzle here. Let me expand it so you see it very well. Good. Now, for all of this car to be able to go, which car will you remove first?
Um. 3.
Are you sure?
Yes.
Yes, you are right. Can you clap for yourself? Clap for yourself. You get it right. Very good, very good. So let us continue. Remember we talked about angular speed, right? Can you tell me the
Yes.
formula again for angular speed? Omega is equals to something divided by something.
R
2 pi over t. 2 pi
T.
divided by t period.
Yeah.
That is the formula
Yeah.
for angular speed. Now, what we are trying to do here is this. Um, I want to talk about the linear speed v. The difference between linear is that linear is a straight line and angular is a circle, it's circular. Are you following? So
Yes.
now we can convert from angular to linear. Are you following? Using this
Yes.
formula, the linear speed v is equals to r omega. R omega. The omega is the angular speed. What do you think the r is? What do you think the r is? Mira, what is r?
I.
What is this?
Oh, angle.
This one?
Right. Right angle
Radius,
line.
radius,
Right.
radius, radius. So the r there means radius. So when you multiply radius with the angular speed, you will get the linear speed. Is that okay?
Yes.
Don't worry, we'll take examples. Do you have a textbook with you?
No.
Okay, no problem. I have some questions here, so we'll take examples. Don't worry. Now, we have talked about linear speed. We have talked about angular speed, right? Then the next thing we'll talk about is acceleration. Remember that when we are talking about in the last semester, we learned speed, velocity, acceleration. Are you following? So that's why we're also learning the same thing also for circular motion. So now, can you read this for me? Centripetal acceleration.
Centripetal acceleration is the rate of change of
Tangential. Tangential
tangential velocity.
velocity. Very good, very good. That is centripetal acceleration. In simple word, when a car or anything is moving in a circle, the acceleration is called centripetal acceleration. Are you following? When you
Yes,
just say acceleration, you mean the linear one. But when you say centripetal acceleration, you mean the circular one. Is that okay?
yes.
Very good. Now, I want to draw something. Oh, no, let me go back to the image up here. Look at this picture. This is a car moving around the roundabout, right?
Yes,
Normally, if this car is moving, it's supposed to be going straight like this. It will be going straight like this. Are you following? But
yes,
because it is in a circle, there is a force that is pulling it. The car wants to go like this, the force will pull it like this. Are you following? When it comes like this,
yes,
the car will want to go again, go straight, the force will pull it again. Go straight, the force will pull it again. So the force is pulling the car to the center of the circle. And that is why the, the car can complete the circle. Are you following? So the car is
mhm,
going straight, the force is pulling to the center. So it will bend. It will go again, it will bend. It will go again, it will bend. And that's why it is now completing a circle. That force is called centripetal force. Can you say that again?
yes.
Okay. What is the name of that force?
The what?
What is the name of that force? Yeah,
Centripetal.
centripetal force. It is the force that pulls, an object that is moving in a circular motion to the center of the circle. It is pulling it towards the center. Are you following? Now let's go back to the equation.
Yes,
No, to the definition, so that you can understand better when you are defining. So can you read centripetal force now? Centripetal force, can you read?
yes.
Okay, please read.
A centripetal force is a force that makes a body follow a curved path. It is directed towards the center of the circle.
Very good. So the force that makes a body to follow a curved path is called centripetal force. It is always directed towards the center of the circle. Is that okay?
Yes.
Aha. Now, what I'm going to do now is this. You are going to take your notebook and your pen. This time around, I will not allow you to run away. So, do you have your notebook and pen there?
No,
Can you get it easily?
no.
Ah, why? You are coming to a class. Astaghfirullah.
This I can do it
Huh?
later and send you.
Okay, okay. Okay, let me explain so that you don't make mistake. Uh, and you can do it and send to me, right? Yes. So let's say Now, the formula for centripetal acceleration is this: v squared divided by r. Are you following? There are three formulas. Look at it here. This is two of them. A is equals to r omega squared, and A is equals to v squared over r. I'm sure you remember that the r is the radius, the omega is this circular angular speed, and the v is the linear speed. Is that okay? Now let us solve
Yes.
this one. Can you read this question?
You are wearing a
Mhm.
ball attached to a string such that you describe a circle of radius 75 centimeter at a velocity of 1.50 meter per second. What's the acceleration of the ball?
What do you think the acceleration will be? What formula do I need to use there?
Uh, A equals R.
A is equals to v squared divided by r. Now, I'm changing the radius from centimeters to meters, so I divide by 100. I have 0.75. Are you following? Then I have my v to be equals to 1.5. Are you following? Meter per second. So my
Yes,
centripetal acceleration will be 1.5 squared divided by 0.75. Are you following? Squared divided by 0.75. This is centripetal acceleration.
yes,
So the final answer will give us the centripetal acceleration. Is that okay? So if you look at the next one, you can see this question now. Now, this one, this is the velocity and this is the radius. Are you following? So A will be equals
yes,
to 25 squared divided by 125. V squared over R. Are you following? Divide by 125. Alas, this is a centripetal acceleration. Do you understand now?
yes,
Is it clear?
yes,
Now, let me talk about centripetal force before we go to the last slide. You know that according to Newton's second law, what is force? F is equals to what? Is equals to mass multiplied by acceleration, ma. Are you following?
yeah, yeah,
Now, this F is centripetal force Fc. So it means the A will be centripetal acceleration AC. Are you following? Already, we have a formula for acceleration. So I will just change this to this one. So I have my F will now be equals to what now? Do you understand that?
yes,
So what will be F? F is equals to, I've changed my A to this formula. So what will be my F now? Wow, it will be M multiply. Instead of writing A, I'll write V squared over R because my A is V squared over R, right? Are you following? Mira, are you there?
yes,
So
yes, yes,
this is the formula for centripetal force. Mass multiplied by V squared over R. Now, remember I told you that centripetal acceleration has more than one formula. This is one of them. You'll see this later also, but just know that it is not only one, it's more than one. So let's go to the last slide and see if we can solve the questions there. This one is talking about centripetal force, and I mentioned that just now. Can you see the formula now? mv squared
Yes.
over r. The Fc is centripetal force, m is mass, v is velocity, r is radius. Now read this question number one and tell me if you can solve it. Can you solve that question number one?
Yes.
What formula will you use to solve it? Now,
FC equals FC equals MV2 over R.
okay, that's good. That's very good. That's very good. So what I'm going to do now is that I will send a worksheet to you. This worksheet is actually an homework worksheet, meaning I'm going to put the score in your file. Are you following?
Yes.
Make sure you do it. It's going to be about this. If you have any question, please let me know. You do this. You print it out, you solve it, take a picture and send to me. Then later when you come to school, you bring the paper for me. Is that okay?
Yes.
So when will you be able to submit that? Today is Tuesday.
Uh, Tomorrow.
Tomorrow. So you print it out, you solve it, take a picture, send to me, keep the paper. When you come to school, you bring the paper for me. Okay?
Yes.
Very good, very good. So I'm going to see you in the next class where we shall talk about math, inshallah. That will be tomorrow. That will be tomorrow. Is that okay? So thank you for coming, and I will see you next time, inshallah. Have a nice day.
Thank you.
Bye bye.
Bye.